All right, let's take a look at graphing some square root and cube root functions. Let's see, graph the following functions. What are the domain and range of each function? Is the function increasing or decreasing? So f of x equals the square root of 3 times x. We have some x values pre-identified for us. That actually is helping to make it a little easier to find nice clean points. We're going to end up with something that we can square root. So if you plug in, let's see, square root of 3 times 0 is the square root of 0, which is 0. I'm going to plug in a 3. Square root of 3 times 3 is square root of 9, which gives us 3. Square root of 3 times 12 gives us square root of 36, which is 6. And then the square root of 3 times 27 is square root of 81, which is 9. All right, so let's plot those points to kind of see what this graph looks like. We've got the ordered pair 0, 0. And let's just take note that we are counting the x-axis by 3s, and we're counting the y-axis by 1s. So we'll just want to be careful when we are plotting these. All right, so the next ordered pair is 3, 3. So I'm going to go over 3 on the x-axis and up 3 on the y-axis is going to put us right there. Then we're going to go over 12 and up 6. It's right there. Over 27 and up 9. And then our function starts at that 0, 0. There's not an arrow on that end, but this would continue forever in that direction. So some things to think about. This function is a square root function. You can square root positive numbers, but you can't square root negative numbers. We would have to bring in I, which we're not going to do that on these graphs. So that's why this is starting at 0, and we're not going to go into the negative side of square rooting negative values. Okay, so that's what the graph looks like. We want to identify the domain. It's all your x's such that if it starts here and it's going to continue forever this way, all of those x's are going to be greater than or equal to 0. If we did interval notation, we would say it starts at 0 and goes to infinity, another way to represent our domain. Our range, so that's the y value. So it starts here and it's going to continue this way. It's going out and up, so it's going to continue forever for all the y's. So all the y's are just greater than or equal to 0. That in interval notation would be 0 to infinity for the y's as well on your range. And then is the function increasing or decreasing? So we approach the function from the left, and then as we follow it along, continuing to the right, are we increasing or decreasing? And this is increasing the whole time. So the entire function is increasing. So that's what a square root function looks like. And again, it's not continuing forever in two directions because we're limited in what we can square root. Now our cube root function, we are not limited in what we can cube root. So you will see this one continue in both directions. We just want to see what those directions are. So let's create a table of values. And our goal is to get numbers that when multiplied by 2, you can cube root. So if you think about our perfect cube numbers, we have 1, 8, 27, 64, and it goes on. We can include 0 in here because you can cube root a 0, and then we can include some negative values as well. So we're going to come up with, let's see, 5. And we're going to start with a negative 13.5 for our x, a negative 4, 0, positive 4, and positive 13.5. So I know those seem like random numbers, but let's see how this is going to actually work out nicely. If we're cube rooting, let's see, 2 times negative 13.5. That gives us the cube root of a negative 27, which is negative 3. Then if we cube root 2 times negative 4, that's the cube root of negative 8, which is negative 2. Cube root of 2 times 0 is just the cube root of 0, which is 0. Cube root of 2 times 4 is the cube root of 8, this gives us 2. And then the cube root of 2 times 13.5 gives us the cube root of 27, which is 3. So these x values seem kind of random, but they are by design to give us nice numbers to cube root. So let's plot those points and see what this looks like. We have negative 13.5, negative 3. It's going to be right about there. Negative 4, negative 2, 0, 0. 4, 2, and 13.5, positive 3. So this just kind of looks like this. Our domain is going to be all real numbers. This is going to continue forever in both directions, so from negative infinity to infinity. Our range, it will continue vertically in both directions forever, so negative infinity to infinity. And as we approach the graph from the left side and head to the right, are we increasing or decreasing this whole time? And this whole function is increasing. All right, so that's in general what your square root and cube root functions look like.